Hello, Stacy. You are getting my voice?
Yes, sir.
Okay. So, I'm sure you remember in the last class we discussed about blood, right? And the different constituents of the blood. Okay.
Yes, sir.
So, in this session, we will be talking about, first of all, the major part of the human circulatory system. That is the structure of a heart, then blood vessels, and the blood we have already discussed that. So, we will start with this straightforward, the very structure of a heart. Okay. So, you see there, the most important thing is heart is mesodermal in origin. You know, from origin point of view, organ can be ectodermal, endodermal, or mesodermal, right? And it is often asked in competitive exams. So this is mesodermal in origin, situated in thoracic cavity in between the two lungs and slightly tilted towards the left. Okay. Hollow pierced is muscular organ, slightly the size of one's fist, average weight 300 grams in male, 250 in female. And you see, it is protected by double-layered structure called pericardium. And within the pericardium, the fluid is there, which is called as a pericardial fluid. And I'm sure we have already studied all these things in even in our class 9 and class 10 syllabus that it is a four-chambered having two auricle and two ventricle, right? So that is the preliminary information about the heart. Please note it quickly so that we can discuss about more first how the sequence of the flow of the blood. Then we will be talking about the cardiac cycle. Okay.
Yes, yes. Good evening, sir.
Good evening, Bhavya. We have just started. Just note it. This is the first slide.
Yes, sir. I just wanted to tell you that I won't be able to speak today. I'm suffering from fever actually.
ओके कोई बात नहीं बच्चा तुम देखो फिर
Yes, sir.
So once done, let me know.
Done, sir.
Okay. Bhavya, done?
Yes, sir.
Okay. So you see, first we are talking about the structural details. Okay. So right and left atrium that is separated by thin muscular wall, we call them interatrial septum. Similarly, right and left ventricle is going to be separated by thick wall interventricular septum, right? Mind it, it is a thick wall in comparison to the septum that is separating right and left atrium. Now, atrium and the ventricle of the same side are also separated by thick fibrous atrioventricular septum. Okay, so in between the two septum, in between the two atrium, that is interatrium septum. In between the ventricle, there is an interventricular septum, and in between the atrium and ventricle, there is going to be atrioventricular septum. Please note it.
Done, sir.
Done? Okay. So you see, there are walls in the heart, right? And in the competitive examination, it is the walls, name of the walls that is often asked. Okay, for instance, between right atrium and right ventricle, there is a tricuspid. Between right ventricle and lungs, there's a pulmonary semilunar valve, right? So this is one that is going to carry the deoxygenated valve, right? Deoxygenated, that is going to check the deoxygenated blood. Now left ventricle to aorta, there is aortic semilunar valve. One thing is very important. You see, there is a one area in which there is a no valve between lungs and left atrium. There is a no valve. That is important. Okay. Now between inferior vena cava to the right atrium, we call them Eustachian valve, right? Superior vena cava, that is Havracian valve. Coronary sinus to right atrium, then Thefsian valve, right? And of course, left atrium to left ventricle, there's a bicuspid valve. So please take a note and keep these valves in your memory, because the questions are often asked from the name of the valve. Okay.
Yes. Turns.
Okay. So we have just seen the different types of valve, right? Now let's talk about what is pacemaker. Now you see, pacemaker is actually made up of the cardiac muscles, right? And these are present on the wall of the ventricle, okay? So what happens that there is a patch of tissue, right? And this is what we call the sinoatrial node. So there are two type of node, SA node and AV node, right? So a patch of this tissue present in the right upper corner of the right atrium called the sinoatrial node. Now, what is the function of the pacemaker? That initiate the beating of the heart. Okay. So in addition to SA node, there is another mass of tissue that is seen in the lower corner of the right atrium. Okay. That is close to the, what we can say, this, the SA node. This is what we call AV node. Okay. So we can see all these things in diagram. So have a look at this diagram, So there is a SA node over there. Okay. And from SA node, there is a AV node. AV node is at the boundary of the ventricle and the atrium. Okay. So the impulse is generated from SA node. From SA node, it transmits to the AV node. And from AV node, it downs to the Purkinje fiber and the bundle of His. We will see all this thing in the next slide. So please write on this. What is the pacemaker of the heart? Okay.
Sir, written.
1 second, sir.
Done.
1 second, sir. Yes, sir, done.
Okay. So you see, so what happens over here? So there is a bundle of nodal fiber, AV, that continues from the AV node and divides into left and right bundle. You can see there. From AV, actually, it divides into left and right bundle. Okay. So these branches give rise to minute fiber throughout the ventricular musculature, and we call them Purkinje fiber. This is what we call Purkinje fiber. Okay. Now, what happens that this musculature has the ability to generate action potential, and that action potential is necessary for the just contraction of the heart or generation of the, what we can say, the impulse. Okay. So what happens that sinoatrial node, they can generate a maximum number of action potential, that is 70 to 75 per minute. And it is responsible for initiating and maintaining the rhythmic contractile activity of the heart. So that is why SA node, right, that is actually called as a natural pacemaker of the heart. And from once it starts, right, you can see in the animation as well, that once it starts, then what happens? That there is going to be, first of all, the impulse generated from SA node, they goes to AV node, from AV node, it goes to Purkinje fiber. And this entire, the ventricle, this is actually called as a bundle of His. And there is a delay of 0.1 second between transmission of the nerve from the SA node to AV node. Okay. So please note it. लिख लिया?
Yes, sir, done.
ओके, सो आर्टिफिशियल पेसमेकर क्या होता है? देखो, जब ये रिदमिक ट्रांसमिशन, इलेक्ट्रिकल इंपल्स जब प्रॉपर ट्रांसफर नहीं होता है, देन वी नीड टू पुट आर्टिफिशियल पेसमेकर। ओके, सो पेसमेकर इज अ स्मॉल बैटरी ऑपरेटेड इलेक्ट्रॉनिक डिवाइस, जिसके अंदर में क्या होता है, देयर इज अ टू पार्ट, वन इज अ जनरेटर एंड सेकंड इज अ लीड। सो जनरेटर क्या होता है? स्मॉल बैटरी ऑपरेटेड एरिया, और लीड क्या होता है? वायर्स होते हैं जो कि हम ये स्किन के नीचे से लेते हुए उसको हम लोग क्या कहाँ इंसर्ट कर देते हैं, तो राइट वेंट्रिकल के पास उसको इंसर्ट कर देते हैं। तो वो उससे जो इलेक्ट्रिकल इम्पल्स निकलता है, वही एक आर्टिफिशियल पेसमेकर की तरह काम करने लगता है। आप समझ गए?
Yes, sir.
लिख लिया?
1 second, sir.
Yes, sir.
ओके, तो क्या होता है? पेसमेकर इज इंसर्टेड इन चेस्ट, राइट? And a wire from the pacemaker then pass through a vein, a purchase and place in the right atrium or right ventricle. Okay, so this is how it is actually being done. Okay,
Yes, sir.
Over.
No, sir. Done, sir.
Okay. So you see, we have finished the pacemaker. Now let's talk about the blood vessels. There are two type of blood vessels, what we call artery and veins. And from artery, we know very well that it is the oxygenated blood that flows, right? So the important thing about artery is that it doesn't have any wall. It lacks wall. So anatomically, it consists of three layers, what we call outer tunica adventitia, that is made up of collagen, middle tunica media, that is made up of smooth muscles, and inner tunica intima, that is made up of endothelial cells. You can see in the diagram also, right? So this is the tunica externa, right? Or what we can say tunica adventitia, that is made up of collagen fiber. Then tunica media, that is the middle one, and tunica intima, right? That is made up of endothelial cell. So that basically marks the blood vessels, and here the blood actually flows, right? So please note it. Clear?
1 minute, sir. Done, sir.
Okay. Now you see, arteries have a thick wall and they are more elastic. So further they are divided into arterioles, right? An arteriole constrict and they are regulated by nervous system to regulate blood pressure because they don't have any wall. So that's why the regulation is going to be done through their constriction. And of course, this constriction need to be regulated by the nervous system itself, right? So you can see there is outer coat, there is the endothelium. Endothelium is a part of epithelial tissue. And epithelial tissues cannot be visualized without the basement membrane. So there we have a basement membrane, and below that we have an endothelial tissue. Okay. So write on this about arterioles.
Done, sir.
Done. Okay. So the blood capillaries, that is the smallest one, right? The important thing in the blood capillaries, they don't have the outer membrane, right? So they don't have the outer collagen fiber. So they have only basement membrane endothelium. So they are microscopic within 16 to 80 micrometer. And mostly they are closed, right? Because they are going to be connected with the venules, but 5% are open. Okay.
Yes, sir. Done, sir.
Done. Okay. Now let's talk about the veins. We know very well veins is going to carry deoxygenated blood, right? So from the vein, there is a venules that take blood from capillaries and join to form vein. Now in
Sir?
comparison to, yeah,
Sir, capillaries are responsible for the exchange of gases, right?
yes, that is
Okay.
present in a systemic system. We will discuss about that. Okay.
Okay, sir.
So you see, walls of the veins are much thinner. And if you compare the arteries and the vein, in case of veins, there is a low blood pressure. And since there is a low blood pressure, they have a wall. Okay. And the wall opens only in the direction of the heart. So it ensures a one-way flow of the blood. Okay. So anatomically, it is very much similar to the artery, except that tunica media is thin. That is very important. anatomically both are same. Of course, the valve is not there, but if you compare the external structure, then they also have a externa, media, interna, right? But tunica media is comparatively thin. That is important, which once I have seen in the NEET examinations. Please note it.
Done.
Done.
Yes.
Okay. So you see, next we need to discuss about the cardiac cycle. Okay. Now let me know, when is your next class? Do you have any class right now?
Sir, from 9:30, sir.
9:30. ठीक है, अभी थोड़ा सा इंट्रोड्यूस करते हैं, देन वी विल टॉक अबाउट इन द नेक्स्ट क्लास। देखो, कार्डियक साइकिल हम लोग कहते हैं किसको है? दैट इज द पीरियड बिटवीन द स्टार्ट ऑफ वन हार्ट बीट टू द बिगनिंग ऑफ द नेक्स्ट। ठीक है, उसी को हम लोग कार्डियक साइकिल कहते हैं। और कभी भी इसको हम लोग दो फेज में डिवाइड करते हैं। एक हम लोग कहते हैं सिस्टोल, दैट इज अ कॉन्ट्रैक्शन, डायस्टोल, दैट इज अ रिलैक्सेशन। ओके, तो ब्लड क्या क्या होता है? ब्लड विल फ्लो फ्रॉम वन चैम्बर टू द नेक्स्ट, और व्हेन द प्रेशर इन द फर्स्ट चैम्बर एक्सीड्स द प्रेशर सेकंड, फिर वहां से वो आगे बढ़ जाता है। ओके, सो द टाइम ऑफ द कार्डियक साइकिल इज द रिवर्स रेशियो ऑफ द हार्ट बीट। ऐसा मानते हैं कि एक मिनट में हार्ट बीट कितना होता है? 72। देन द टाइम ऑफ कार्डियक साइकिल क्या हुआ? 60 डिवाइडेड बाय 72, यानी 0.8 सेकेंड, यानी वन कार्डियक cycle is completed in 0.8 seconds. So that is important. Okay.
Yes, sir.
Please note it.
Done, sir.
Done? Okay.
Yes.
So what you see, the cardiac cycle can be divided into these stages. Right. First, auricular systole. That means contraction of auricle. It takes 0.1 second. Then ventricle systole. That means contraction of the ventricle. It takes 0.3 second. And then there is joint relaxation. That takes 0.4 second, right? So altogether, if you calculate, it is going to be the 0.8 second. And that was the total time duration of the cardiac cycle. Okay. So, the two sound we used to hear, lub, dub, right? So closure of the AV valve, that sounds give the love, and the closure of the semilunar valve, that gives sounds the dub. Okay, please note it.
Sir?
Yeah.
Sorry. Sir?
Yeah, tell me.
Sir, in the last point you have written that vent sorry.
So what is the last one?
Yes, in the last point you have written that the ventricular diastole
Right.
means the dub sound occurs
So,
during the ventricular diastole, sir?
no, ventricular diastole, or what we can say joint diastole, the semilunar valves are going to close, right?
Yes, sir.
Okay, so by the closure of semilunar valves, what we see that there is a sound, right? And that sound gives the dub sound. Okay,
Right, sir.
understood.
Yes. Right.
Done? Okay.
Yes.
Then let's talk about the one that what we call auricular systole. So here what happens? The very contraction of the auricle is going to happen, right? Okay. So prior to auricular systole, what happens? The heart is at a stage of joint diastole. So in this stage, what we see that all the four chambers are at the relaxed state. Okay, from there, the very process is going to begin. So what happens? That deoxygenated blood from superior and the inferior vena cava enter into the right auricle, right? And at the same time, oxygenated blood through pulmonary vein enter into left auricle. Okay, because you know very well both auricles are going to contract simultaneously, right? So when they contract, what happens? That the tricuspid on the right ventricle side and the bicuspid on the left one, they are going to open. Okay, and once they open, the blood flow from left and right ventricle respectively to the left and right atria, right? So they are entering into left and right ventricle through the left and right atrium. Okay.
Yes, sir.
Over.
1 minute, sir. Yes.
Okay. So the next, what we see in case of auricular systole, the semilunar valves are closed at this particular stage, right? Because from the semilunar valve, the blood goes to the lung. So that's why it need to be closed. Okay. And at that time, that is SN, that is sinoatrial node, generate an action potential. And that stimulates both the atria to undergo simultaneous contraction. This is what we call atrial systole. एक बात ध्यान देना है यहाँ पे, at the end of the atrial systole, क्या होता है, वेंट्रिकल के अंदर में अप्रॉक्स 130 ml of blood होता है, right? And this 130 ml of blood is actually known as EDV or end diastolic volume or preload. That is important. So this is often asked that what is the value of EDV, that is end diastolic volume, right? That is equivalent to 130. और वो कब हो रहा है? when the atrium is going to contract. As a result of contraction, the ventricles are going to contain approx 130 ml of blood. Okay?
Yes, sir.
Note it. तो देखो यहां तक हम लोगों ने क्या देखा कि दोनों एट्रियम कॉन्ट्रैक्ट हो गया, एट्रियम कॉन्ट्रैक्ट हुआ तो हमारा क्या हुआ, बाइकास्पिड वाल्व खुला। ओके, और उससे क्या हुआ, फाइनली हम लोगों ने क्या देखा, ब्लड जो है वो एट्रियम से वेंट्रिकल में आ गया। टोटल अमाउंट ऑफ ब्लड जो आता है वो है 130, जिसको हम लोग ईडीवी या एंड डायस्टोलिक वॉल्यूम कह रहे हैं।
Right. Yes, sir. That's
Done? Okay. So next we will talk about ventricular systole, where the contraction of ventricle is going to happen. Okay. So both left and right ventricle is going to contract, right? And what happens when ventricle systole increases the ventricle pressure? So that pressure initiate the very closure of the valve. Which valve? Cuspid and tricuspid and bicuspid valve, right? And this closure is going to produce the sound lub. So as the ventricular pressure further increases, what will happen? Semilunar valves will open, right? So semilunar valves will open. So the blood from right ventricle will go to the lungs, and blood from left ventricle will goes to the aorta, right? Please note it. लिख लिया?
1 minute, sir. Done, sir.
Done?
Yes, sir.
Okay. So I think okay. चलो फिर आज यहीं पे छोड़ते हैं, राइट? क्योंकि हमारी फिजिक्स की क्लास चालू होने वाली है ना।
हाँ सर।
अभी इसके बाद ना हम लोग फिर से कार्डियक साइकिल में जितना पॉइंट डिस्कस किया एक बार रिकैप करेंगे एंड अगेन वी विल स्टार्ट ऑन सैटरडे, राइट?
ठीक है सर।
चलो, ओके, थैंक यू।
थैंक यू सर। बाय सर।